All right, welcome everyone. In this video, what we're going to be looking at is chapter one of our textbook. In there, it's labeled as Design and Contracting Requirements. I'm calling it General Requirements. Same idea. This chapter one is going to be broken into two different lectures. There's the one today and the other one on Wednesday. So this corresponds to the book chapters 1.1 to 1.5 if you're following along and reading along in the textbook. So let's start with talking about the overall objectives of the design. Why do we even, what do we want to accomplish here? And really, it depends on what is its purpose. So we need to design it to do what it's supposed to do. I think that should go without saying, but it's written down. So we also want to be very efficient, and we want to take into account the occupants and their health, and also any environmental impacts that producing the building might have. So when we dig down a little deeper into what kind of considerations we're looking at with design, it can be things such as like the cost and the appearance and what climate it's going to be in, and topography and maintenance costs. And you can go through and read all this. Some of these can be variable, meaning something like a maintenance cost. Well, you could design it with a more maintenance-free material, or what else? If you were to talk about the availability of resources, well, everything's available, just a matter of how much you want to spend on it. However, some things are not as variable. Something like zoning codes or zoning and codes. Those are, you can't get around it. You have to meet these minimum requirements and build based on wherever you're building. Meaning, if it's a residential building, you can't build it in a commercial district. Things like that. So you can read through those, but those would be more considerations that you should be looking at during the design process. When we talk about the design team, who else involved, we can see up top we have the owner. This is who initiates the whole design, the building, the shouldn't really say design, really initiates the project. And then the design itself is done by the architect or the engineer, or possibly a design team, which consists of architects and engineers. It somewhat depends on the project. If it's like a bridge overpass, you're not going to have architects. You're going to be basically engineers designing it. If it's I don't know, if it's a piece of art, or if it's a very artistic building, of course, the architect would be in charge. And once you have your design team in place, now they're the main branch that's responsible for everything else. So over on the right, we can see what they do is they produce this project manual and also the drawing. So they'll produce the drawings that the building or structure will be built based on, and also a manual on any other requirements and codes and everything else that have to be met during this project. During that, they have to determine all these A, B, C, D, E, F, G's. So legal issues, financial issues. They're going to draft up the contract documents and everything else. So note this may also include the general contractor as part of this team. If not, then the architect and engineer usually start off by looking for a general contractor. I'm labeling this as just a constructor, so it's the person who's responsible for putting this whole thing together and actually building it. But usually it can be termed a GC. And then the contractors may hire out subcontractors, and they may hire out even subcontractors, and so on and so forth, depending on the specificity of what needs to be done. So industry standards, this is the difference between being in class and doing this online right now. So in class right now, I'd probably do a little question answer, see if you know what an industry standard is, do you have any examples, so on and so forth. If you want, you could probably take pause this video and see if you can think of one, and come up with a reason on why, and come up with an example. But then that'll hopefully happen throughout all these presentations, where you have these opportunities to do your own self-reflection, I suppose, right? Who knows? But industry standards, why we have them, or what are they? It's basically this level that we need, this minimum level to make sure that everyone's safe and we have high quality and everything's going to do what it's supposed to do. If I have a cable and I need it to hold 1,000 pounds, and I can do the math and figure out how big this cable needs to be, well, if the material doesn't meet the minimum standard, then all that math doesn't matter. It breaks and we kill people, which is never a good thing. So we have these standards to ensure that that when we come up with our structure or project, whatever we're working on, that it will meet that minimum requirement. And you can see there's different types of standards. There could be a material standard. That's kind of what I was talking about a second ago, like how strong a material might be. There could be a product standard, a design standard, or even workmanship and how different things are put together. And here's a little more detail on those. So material, type of standard, description, well, it defines the properties. And then if you go over here to example, we'll talk more about these organizations just a little bit, like an ASTM A325, which is a type of bolt. And you can see here it has this 120, 105 KSI minimum tensile strength. So what that really is saying, if I were to drill down, is it's 120 KSI stands for kips per square inch. So we have 120 kips per square inch. And I believe, if I'm not mistaken, 120 is if the diameter is over 1 inch, and 105 if it's less than 1 inch diameter for the strength of that bolt. And you can actually buy a bolt then at the hardware store, and it'll have A325, and you'll know how strong that bolt actually is. So that's an example of a material property. Could also have a product. Also, this is ASTM as well. This might be like you have to use this certain type of product or this type of liquid membrane or whatever you're going to be using for that particular design constraint. You can be a design, such as what are you gonna have for a product or a system? What kind of requirements are there for, like, say, structural concrete? How strong does that structural concrete need to be, or what components need to be in there? And we'll talk more about concrete later as well. But what's the percentage of aggregate, fine aggregate versus sand, or something like that? Workmanship. After the installation, maybe you can be an 1/8 inch off on a joint in a building or something. What type of standard do you need as far as when you're putting everything together, the actual physical workmanship on site? And then last, testing. Testing is a protocol. For instance, for those who go on to take 251. Con 251, we talk much more about this because it's material testing is the name of the class. And ASTM, this organization, actually comes up with these testing specifications. Meaning, if you're going to see how strong concrete is, how many tests do you have to do? How many samples do you need to prove that's that? And what's the test look like? What's the machine you're going to use? All that type of testing protocol or testing standard would be another type of standard. So those are all the types of standards: material, product, design, workmanship, testing. Who writes them? There's a lot of organizations who come up with these and write them over over the years, and you can see that there's some organizations involved like ASTM, ANSI or ANSI, Underwriter Laboratories, that's electric, and NSF or NFPA for fire, and there's a lot. There's many more than this. This is just a small sampling. You will notice, like, if we were to go back a this slide. We have ASTM, ASTM, ACI, which is concrete, and then ASTM. ASTM, it looks like they determine most of them, but really what ASTM really is more like a clearinghouse. They collect all the standards from these other organizations, and they work with like UL or whoever else to develop this master list of standards. So that's why we saw ASTM so much on the other page. And by the way, you can go to the library and look at the hard copy of all the ASTM volumes for different types of construction. So it looks like here's a couple examples. There's a bolt. We're just talking about bolts, A325. Like I said, stamped right on there, so I know the strength of that bolt, 120 kips per square inch, or 105 depending on the diameter for the minimum tensile strength. And you don't have to know that particular standard. It's just there as an example where you could do that with just about anything. This is like a product standard where we talk about liquid membrane or the forming compounds for carrying concrete. So, and you could go to these links. I don't think I'm going to waste our time. Actually, this link wasn't working for me earlier. I have to figure out why. This should bring us to the ASTM standards through CSU, and I don't know why it wasn't quite working out. I have to look into that. And then maybe you want to try it out, see if you can get it, enter your EID and things. And then over here, this would be for the material one. But I'm trying to keep these videos a little shorter because I think that 45 minutes of me talking is just, it's got to hurt your head after a while, right? So you can take your time and plop through these if you want. They're just links to web pages. This will have a whole bunch of different material standards you can look at. Like I said, that's the ASTM one. We also have, outside of standards, we have codes. So standards are more like what's our minimum requirement as far as materials and products and things. And codes are more like the laws that govern how we're going to build our buildings, where we're going to build them, and what they're going to look like, right? So you can have either zoning, building, or model codes. For zoning codes, you're probably familiar with this. Like, if you probably noticed that houses are usually next to houses, like, it's a residential zone. So we have zoning in order to control, what type of structure, what type of business will be housed in one type of structure based on location and things like that. And so you can see you have agricultural, residential, commercial, factory, and based on that zoning, it'll affect what you're doing in there. Are you going to be selling things? Because pretty soon you might not be a residential. You might be violating some of your codes if you started changing the use of the particular building or structure. This is a link. I know I said I wasn't going to do this. Let's go ahead and take a look at one anyways, because I feel like, I don't know what this is. Let's see if you can see this. Something like that. So this is Fort Collins. If you were to click on that, there's their building codes. I don't want to spend too much time on this, but you can see they're showing, like, if you were to design for snow, you need to design for 30 pounds per square foot and treat it as a live load. And it's more of an engineering type thing. But they also have a link to say, if you're going to do anything, and then they're linking to other codes, like this is the IBC, the International Building Code. So that means that City of Fort Collins is going to follow the IBC, and they may have some amendments. I think they showed some amendments on the other side. And then there would be, and you could spend days in here. It's better if you know what you're looking for, like, means of egress. How are you going to get out of your structure or whatever you're doing here? And there'll be all sorts of sections and subsections and ceiling heights and headroom and, so on and so forth. So, it'd be a good exercise if you wanted to go through and look at some of these codes, but they feel very lawyer-esque, and they're it's, I find that for me, it's always been, what am I trying to do? Am I going to build a small shed in my backyard? If so, what I go to the City of Fort Collins website and say, okay, well, what is required for permitting? What kind of codes do I need to follow with electrical and maybe HVAC in there or something like that? But regardless, that's City of Fort Collins. See if I can get back to this presentation. There we go. So that was zoning, and we also have building and model. Whoa. Under building codes, we're really looking at safety issues. So, that's the purpose of these codes. First and foremost is to make sure that we're not hurting anyone. You can see it's enforced by local officials, adopted by entities. You can read, but really, I think what you'd need to know is that the zoning is based on location, what you're going to be using the structure for. The general building codes are more about the safety issues to make sure that everything's going to hold up the way it's supposed to. And then model codes are basically the big overseeing organizations that develop these codes. And like I said, the City of Fort Collins said, well, they're going to use UBC. They're going to use that Uniform Building Code as a guide, and that's really what those national building codes are for. So they there you go, provide a good resource for local communities needing codes. So you might start there as a community and then say, okay, now how do we need to modify it to fit our particular needs? But yeah. Section 1.4 is about this barrier-free design. In essence, barrier in this case is referring to anything that would keep the inhabitants or the people using the structure or whatever from being able to. So we're saying that it has to be accessible, building accessibility. So depending if you're old like me and you need, you don't do well with stairs or something, or need a handrail because you I don't know, whatever reason. But it's really, and this is where I think there's been a lot of changes in the last 20, 30 years, is where you're starting to see more and more accommodations so that everyone can use the structure of the building. And these are governed by law. So from the America, but with Disabilities Act and also Federal Fair Housing Act. It's required now that whenever a structure is built that it will address all these issues. And not that long ago, you'd find something where maybe there's a series of toilet stalls and they're all the exact same size, and there isn't like a handicap one. Right now, go in any place and there'll be a wider stall with rails or something specially made for whatever disability someone might have. There's some more. So you might have whether the intent, of course, is safety or accessibility. I hit more on the accessibility. Safety is somewhat the same idea, though, but make sure things aren't too slippery and make sure there's proper lighting and things like that. And you can read the rest of that slide, but yeah, there you go. Section 1.5, this is still under the special design considerations. Something else we have to really think about when it comes to construction is the amount of environmental impact it actually has. Because the building process is massive. It takes a massive amount of resources and energy to build something. And I mean, you can see these numbers are kind of crazy. Like CO2 emissions, 39%, almost half of all CO2 emissions is from some process along the building of a building. And this includes like from the making of the materials to the transporting of the materials, to the construction of the materials, to the workers driving their trucks to the site, to everything. I mean, there's a lot to it, but it's still 39%. It's a pretty massive greenhouse gas emissions factor, right? 40% of all raw materials, and then 39% of all energy. So, and this has definitely been hit on more recently. It used to be the fact that there weren't as many regulations, but as we see more and more environmental impacts, then I think it's becoming more and more built into the design considerations when designing and building these structures. So each chapter within our textbook will contain a little section on sustainability to help address this. Along that, there's also the green building, or green is in environmentally friendly, and really this was established or governed by the EPA, the Environmental Protection Agency, and it's basically like how can we decrease some of these big impacts we're having, both in the building process, but then also once it's built with the use afterwards, more energy efficient or possibly self-generating electricity with solar panels, whatever else. So the EPA is responsible for that, looking at all the aspects of the green building process. And as one measurement, there's something called LEED, and you can become LEED certified. And what LEED certified basically means is you are very environmentally friendly. And this is an example of a checklist. And no, this isn't required by law. This is something that is as a builder or as an owner or whatever else, as an organization, as a community, you can decide to go above and beyond and become certified as being a green building or a LEED certified. And it's based on these scoring charts. Then there's different levels within LEED. You have reached the gold standard of LEED. You can see here's gold, platinum, silver. What is this one? Just green? I don't even know. It just said LEED certified. I guess that's basic one. Oh, it does say green on there. Nope, that's the green building. I don't know what that one is. I guess that's just LEED, then silver, then gold. Whatever. But regardless, there's different levels of LEED that you can achieve based on how well you score on this type of stuff. So that was it. So I hope you found that somewhat informative, and look forward to the second part of this chapter 1 in the next video. Thanks. See ya.